there. All right, so now that we have mastered graphing sine and cosine, we're going to go ahead and throw in the other 4 trig functions. Now, if you were in class, you would see that we had taken all of those angles that I had split up. Everybody was responsible for some angles, and we made this big old XY table, and we used it to graph these. Since you're not there to see that, we're just going to jump right into how to graph them. As we're doing these graphs, I might recommend that rather than putting them in your notes, you put them on your master list where we put our original sine and cosine parent graphs. Go ahead and put these 4 new ones on that same sheet rather than in your notes. So let's start with tangent. Now, basically, you're basing this off of the unit circle, and we just start kind of plotting some points. If you think of the unit circle, the tangent at 0 degrees or at 0 radians is 0. And it's 0 at there and at pi. And really, it's that it lands every time, every version of pi. So at pi, 2 pi, 3 pi, 4 pi, as you're wrapping around the unit circle, the value of tangent is 0. Now, it is undefined when you're straight up and down at pi over 2 and at 3 pi over 2. And then as you wrap around the unit circle, every time you're straight up or straight down. So undefined indicates that it is a asymptote. Okay, and then what we did is we kind of just, well, how about this? How about at 45s? Those are easy. At 45s, the tangent is 1 or maybe -1. Thinking about where that would fall, here's my 45 or my pi over 4, because here's pi, so this would be a fourth of the way there. This is pi over 4, and at pi over 4, the tangent value is 1. So I'm going to plot a point right here at 1. But if I had gone to negative pi over 4, it would have been in the 4th quadrant, and it would have been -1. If you keep on going around the unit circle and pick out some of these key spots, here's pi. This is going to be 3/4 of pi, and that's the 2nd quadrant. Tangent is -1 there, but then it's going to end up +1 here, and we get this little pattern of these little lines that now they look almost like, well, they do, they line up perfectly. However, they're not linear. The graph actually looks like this. It's getting really close to that asymptote. It comes and swoops up here through those points and goes and approaches your asymptote. And then it repeats over and over and over. Now, a couple things to consider. When I said that this happens at the 45s, well, ultimately, this is all very symmetrical. What you're going to do is the same thing I just did, is you're going to identify where your x-intercepts are. Tangent is supposed to start at 0, so it would start right here, but maybe you have some phase shift or something to deal with. And then once you've identified where all of these go, then you insert the asymptotes in between the x-intercepts. They fall directly in the middle of the 2 intercepts. Likewise, this value, this point at 1, is always going to fall right between an x-intercept and an asymptote. If this gets stretched out because the period is bigger, this is still going to fall in the middle of these 2. It doesn't always just fall one grid line off of this. A lot of people want to do that, but it falls in the middle. Something that's new with tangent that's different from sine and cosine is the period. If you look at this, you can see that this is repeating every 4 grid lines or every pi. That's new. The domain, just like not just like we did. In sine and cosine, the domain was -infinity to infinity. The problem with tangent is you have all these asymptotes in here. So it's not a nice continuous function. To list our domain, we basically just state what x cannot be. I'm going to say that x cannot be, and looking at where my first positive asymptote would be right here. at pi over 2. So x cannot be pi over 2. But then it sits there and repeats that every 4 grid lines, which is pi units. So we're going to tweak this a little bit to say x cannot be pi over 2 plus every pi n. And n is defined as an integer. It will dictate how many times you add pi. Well, every time you add another pi, you put in another asymptote. It could even be negative, which is what's going to allow you to go back and put in these asymptotes. There's your domain. Your range, however, goes continually down and continually up. That one is a negative infinity to infinity. It is an increasing function. It starts at the intercept, the x-intercept. That's your starting spot. That will change. So this is like remembering that sine starts at the middle, at the x-intercept, and heads up, whereas cosine starts at the peak. You've got to know where it starts. This another is a new thing here. Remember that amplitude is half the height of the wave. What is half? Well, if you look at your height of your wave, this is an infinitely long wave. And what's half of infinity? Well, it's still infinity. We do not actually deal with amplitude of these graphs. It doesn't have any purpose. It just is not applicable to a tangent graph. Now, there might be an A value in front of your equation, which might have some vertical stretch or reflection. That still plays a part. But we are going to say NA for amplitude, not applicable. We don't even talk about it. Cotangent is the reciprocal of tangent. And if you think about all those places that I was putting 0, remember that the reciprocal of 0 is actually undefined. And the reciprocal of undefined is 0. This becomes basically a shift of the tangent wave. Tangent had an x-intercept right here at 0. That means I'm going to put an asymptote there. And the period is still going to be pi units, which means I'm going to put an asymptote every pi units. Where tangent was undefined at the pi over 2 mark, that's going to be an x-intercept now. And that's going to be the case for all of these. The other thing that it's going to do is when tangent was very, very low on the graph, when tangent was low, cotangent's going to end up very high on the graph, making that wave, oops, let's go ahead and put the 1. I'm going to go ahead and hint at this, making the wave swoop downward. This is a decreasing function. Still going to hit at the 1 marks, but they're going to go backwards from how they did on tangent. The 3 points are going to line up this way. Making this wave swoop through looks very similar. Ultimately, it's a reflection and a shift of the tangent graph. There we go. Tangent is a decreasing function, or sorry, cotangent is a decreasing function, and it starts at, look at what it starts at. It doesn't start at an x-intercept, it starts at an asymptote. That'll be the first thing that you plot. And it might have to shift due to some phase shift. Domain, very similar. You're going to list what x cannot be. And the very first asymptote is at 0, meaning x cannot be 0, plus every pi n. And ultimately, you could leave out the 0. That doesn't really do anything. You could just say x cannot equal plus or minus pi n. I kind of like the 0 because it designates where the first asymptote is going to go. Range, just like tangent, negative infinity to infinity. Let's practice one of these. All right, this one's going to be a tangent wave. Let's go through this start to finish. You're going to read your graph left to right. And remember that you typically want to factor out the b value, but that isn't going to really matter on this one because there's not a phase shift going on. Factoring the 1/2 out isn't going to do anything. I'm going to leave it be. Let's go down the list. I see a negative. But remember, the amplitude has nothing to do with the tangent graph. So my official answer is not applicable, not even talking about it. However, that -3 is going to do something. I'm going to put it there as a reminder because otherwise I'm going to forget about it. It does affect my graph. We just don't call it amplitude. The period, remember our rule for that is the parent period over b. And the parent period for tangent was only pi. Yesterday, or for sine and cosine, it's 2 pi. But for tangent and cotangent, it's pi, meaning I'm going to do pi divided by the b value. Dividing by 1/2 is the same as multiplying by 2. I've got a period of 2 pi. There is no phase shift. I'll put a 0 for that. And there is no vertical displacement. I'll put a 0 for that. Again, this over here, remember the parent period is pi. That affects right here when you're doing your formula. Okay, next. Remembering where tangent starts. Tangent starts at an x-intercept. It's going to be right here. And I even get to leave it right there because there is no phase shift. The next time I'm going to be at this spot is 2 pi units later. So I'm going to put a dot there. Another 2 pi is right there. I'm going to put asymptotes in between the x-intercepts. And now I'm going to work on that -3a value. That is going to reflect my tangent graph. And it's also going to stretch to 3. It's going to actually flip and make it look like a cotangent. It's going to become this decreasing function. When I'm plotting points here, remember I had a point right here at the 1 mark. I'm actually going to have to make it at the 3 mark. It's going to be right here. And notice that this is not just one grid line off the x-intercept. It's in the middle of the x-intercept and the asymptote, stretched up 3. So flipped and stretched. That point, and then you're going to have a point right here. Let's do that a couple more times. In the middle, up 3. In the middle, down 3. 3. Okay. All right. And then what we're going to do is make a nice little wave. Come in here, start to turn, and then on down and approach the asymptote. Here we go. Kind of keep it straight, and then it starts its turn, and then goes back straight. There you go. Let's do a little bit harder one. This is a cotangent. This one does look like it has some phase shift. This time, though, I don't have a b value, so I don't even have to worry about factoring it out. Amplitude, not applicable. But in parentheses, I'll go ahead and put that 2 there so I don't forget. The period is pi divided by b. B is just 1, so the period does not change. It's just going to be pi. Phase shift, remember that it does the opposite inside these parentheses. This is a plus, so that means I'm going to go have a negative phase shift. Instead of going right pi over 2, I'm going to go left. So we call that a negative pi over 2 phase shift. And then we have vertical displacement. That's anything that's gone up, and I do not have any of that. I'll put a 0. This graph is a cotangent graph. Cotangent graphs start with asymptotes right here on the axis. However, that asymptote is going to have to shift back pi over 2. It's going to be right here. Let's go ahead and put our asymptote there. And the period is pi, so I'm going to have an asymptote every 4 grid lines. All right, next thing I'm going to do is put in my x-intercepts. That happens smack dab in the middle of the asymptotes. So right there, and there, and there. All right. Now, I do have before I get in my extra points, those 45 marks, remember it's stretching 2. And it's a cotangent, so it's a decreasing. So I'm going to have this point, and I'm going to have that point. Decreasing function. Oops. Stretch it 2. And then let's go draw our waves. Looks like the last one, because the last one was a tangent that got reflected. It looks like a cotangent when it does that. Tangent and cotangent are similar to sine and cosine in that way, in that you can't really tell if you're looking at a sine wave or a cosine wave because it might just be a shift of the other. I will have to tell you what we're looking at. All right, there it is. Now that takes us to cosecant and secant. In the same way that we used kind of the reciprocal, or really the unit circle and then the reciprocal to kind of figure out how to plot these, since we don't have all the big table of values to do that it's in the video, we're going to do it a different way. Consider cosecant. We're going to start with cosecant. That is the reciprocal of sine. To graph cosecant, I'm just going to graph a sine wave to start with. So very lightly, it doesn't need to be really bold, but remember that a sine wave starts at 0, and then it has a period of 2 pi, so it's going to go to there. It's going to look like this in that space, so halfway between them, I have another x-intercept, and then I have a maximum here and a minimum here. Try to keep that going the rest of the way. All right. Now, that's sine. But cosecant is the reciprocal of sine. And just like we did with tangent and cotangent, if sine is going to be 0, then cosecant is going to have to be undefined, meaning all these places on the x-intercept are going to turn into asymptotes. So I made those kind of big, bold points so you could see them, but really it would be best if you didn't make those big, bold points. It's not really an x-intercept. It's an asymptote there. Now, let's look at what's left. These ones right here at 1 or at -1, that's what's left. Well, what's the reciprocal of 1? Still 1, meaning that my cosecant graph is going to hit this dot also. The cosecant of -1, the reciprocal of -1 is -1. So again, my cosecant graph is going to hit that. What's different here, what's the shape going to actually do? Here's what I kind of consider. The closer you are to the x-axis, that's going to have a small y value, and meaning a small sine value. The smaller the sine value, the bigger the cosecant value, because they are reciprocals. Right here, when sine is very small, in this space, well, that means cosecant is really big up here somewhere. And then it's going to touch right here, and then it's going to start getting, again, closer to the x-axis, making my sine value smaller, making my cosecant value larger. What ends up happening is it kind of inverts this a little bit, and it comes down, touches that spot at 1, and back up. Again, the closer I get, that sine wave would get to 0, the farther up the cosecant is going. But we also have to have this downward shaped U. Looks like that. These are going to alternate, up U and a down U. Right, there we go. I bet you could guess how we're going to graph secant. We're going to make all the points for cosine. All right, I'm going to move faster through this one. Cosine starts at the top, right here. The period is 2 pi. I'm going to be there 2 pi later. I could also back it up 2 pi. And those are my peaks. Between two peaks is a valley. So there's my valley. Here's a valley. Between, I actually could do a valley right here, I guess. Between peaks and valleys, you're crossing the x-axis. This is the cosine wave. I'm not actually drawing the wave. I'm just trying to identify some points so that I can use them to graph my secant graph. Anywhere that cosine is 0, secant is going to be undefined. And then I'm going to do the U-shapes so that they hit those points. Oops. Make sure you're approaching your asymptote there. All right, I'm going to call that good. Now, what do you think the period of this is? Might be tempting to say pi, but the full period has to have one upward U, but also one downward U. The period is the same as it was for sine and cosine. We're back to 2 pi for the period. Keep that in mind. We would need that. Your domain, I don't have it written, but it's on your master parent graphs. Looks like x cannot be 0 plus every pi n. And range, now this is different. Range is going to go from negative infinity all the way up to negative 1. That turns around. In union with, I'm going to pick right back up at 1 and go to infinity. And that's with all brackets on those. Let's practice a couple of these and then we're going to be done. In the same way tangent goes off to infinity and thus can't really have an amplitude, secant and cosecant don't either. They also go off to infinity. Amplitude is not applicable. However, there is a reflection going on this one because there's a negative there. I'm not going to pull out the b value because there isn't one, making the period be 2 pi over 1, or just 2 pi. And phase shift looks like it's going to go have a negative pi over 2 for a phase shift. And there is no vertical displacement on this graph. It is a secant graph, which means I'm really going to graph cosine. Cosine starts at the peak at 1. However, it's going to have a reflection, meaning it's going to actually start down at the bottom. I'm going to have a dot right here. The next time I'm going to be here is 2 pi units later. Right there. And then again there. Between x-intercepts, well, yeah, sorry, those are not x-intercepts. Those are the minimums because of the reflection. Between minimums are maximums. Got one right there, and even over here. And between maxes and mins are x-intercepts. Remembering from earlier, my x-intercepts are going to be asymptotes. I'll go ahead and throw some asymptotes at it. Another one here. All right, lots of asymptotes in here then. And then once your asymptotes are drawn, then you draw the U-shaped things. So here we go. And there we have it. All right, not too bad. It's mostly just a kind of a review of that sine and cosine graph. And once you have it graphed, you have all the points you need to convert it to a secant. Last one. I wanted to do a messy one, so here we go. It's messy for sure. I've got a b value. I've got to factor out of this one finally. Let's do that. Negative cosecant. Factor out the 1/2. Then you're left with x plus. Remember, you're dividing by 1/2. That's the same as multiplying by 2. That's actually going to turn that into a pi right there. No vertical displacement to worry about. Amplitude. Not applicable. It will reflect, but still no stretching. Period. All right, the period is going to be the parent period, which is back to 2 pi. The tangents are pi. Everything else is 2 pi over b, which is 1/2. Dividing by 1/2 is the same as multiplying by 2. I end up with 4 pi. Looks like I've got a negative pi over 2 for phase shift and 0 for vertical displacement. Whoops, 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 whoops. I looked at the wrong one. I'm not looking at the top one. I'm looking at my new one after I factored out. It's a negative pi for phase shift. To graph a cosecant, I'm really going to graph a sine wave. Sine waves start at the 0 headed up. So hover right here, but then let's adjust because I have a phase shift. This point is going to go back to here. And that's my first point. The next time I'm going to be there is going to be 4 pi later. Okay, all right. That was going to be there. That's going to take me that much space to make one period. Really what I'm doing here is a sine wave. It looks like this. However, it got reflected. So instead of being at 0 headed up, I'm going to be at 0 headed down. And it's going to do this. Halfway between the 2 points I've got, I'm at another x-intercept. Halfway between the first two, I'm at the bottom, which is really just at 1, negative 1. And then the next one, I'm at the peak at positive 1. And then over here, I'm at negative 1. Is this making sense? You getting it? That's the sine wave. I don't want the sine wave. I want the cosecant graph. Anywhere sine is at the x-axis means cosecant is going to have to be undefined and thus have an asymptote. Then you draw these U-shaped things in here to touch right at that point and keep on going. Can't get very many waves in here before it's off the graph. Just do your best. There we have it. All right, that's all I got. Good luck. Do good.